Well, hello again. In follow-up to the last video I posted, I wanted to give you kind of an opportunity to evaluate your understanding as well as to go into a little more detail into some of the receptors that we spoke about. So I'm going to basically pose a number of multiple choice, true, false type questions. And feel free, if you're working with this at home, to pause it, and then I'm going to go over the answers. So very test-like application questions that will hopefully provide a little bit more understanding as we go along. All right, so moving right into it, kind of a look into some of the anatomical differences between the autonomic nervous system branches. So concept checks, true or false? The sympathetic nervous system has preganglionic fibers originating from the thoracic and lumbar portion of the spinal cord, and the parasympathetic nervous system has preganglionic fibers originating from the cranial-sacral portion of the spinal cord. All right, that's going to be true. That's exactly what we said, and kind of give you a little picture to illustrate that. This is what you're going to see. So this is our sympathetic nervous system arising in the thoracico-lumbar region, and here's that preganglionic neuron with a cell body right within the spinal cord. And the parasympathetic nervous system is going to be, we're going to have our preganglionic fibers right within that cranial-sacral region. Right. Next question. In the sympathetic nervous system, the preganglionic fiber is relatively long, and the postganglionic fiber is relatively short. In the parasympathetic nervous system, the preganglionic fiber is relatively short. Okay? So this one's going to be false. Okay, so it's the exact opposite. In the sympathetic, we say there's a short pre and a long post. Parasympathetic, long pre, short post. And again, going back to this picture, you can see that. Here's our sympathetic, preganglionic within that spinal cord. That's where it originates from. Short pre, long post. Parasympathetic, long pre, short post. So not the most important thing in the world. It's kind of some anatomical differences to note. But of course the fun part is the physiology. So we're going to look right into that. All right, so next question. Cholinergic corresponds with acetylcholine, and adrenergic corresponds with norepinephrine or epinephrine. All right, that's going to be 100% true. Anytime you see ACH, whether it's released from a fiber that's a cholinergic fiber, or if it binds with ACH, it's going to be a cholinergic receptor. Same can be said with norepinephrine or epinephrine. All right, so that is true. Next question. Two types of cholinergic receptors are alpha 1 and 2 and beta 1 and 2. And the two types of adrenergic receptors are nicotinic and muscarinic. All right, now this is going to be false. So this is if you basically reset this kind of vice versa, the two types of cholinergic receptors are nicotinic, which we're going to find on those postganglionic cell bodies in both branches, and muscarinic. And muscarinic is going to be found on the effector innervated by the parasympathetic nervous system. The two types of adrenergic receptors, so adrenergic binding with norepinephrine or epinephrine, are going to be alpha 1 and 2 and beta 1 and 2. Okay, so don't be confused if you see nicotinic binding with acetylcholine. That's true because nicotinic is a type of cholinergic receptor. Next question. Postganglionic cell bodies receptors are cholinergic and nicotinic in both the sympathetic and parasympathetic nervous system. Okay, I might have given that one away, but that one's also true. Okay, so if you go back to the drawings that we did in the previous video, we'll see that that's exactly the case. You see that ACH binds to these cholinergic nicotinic receptors on both postganglionic cell bodies. So to add to that, where we'll also see these receptors are on the adrenal medulla itself, and then also within that motor unit and that motor end plate of the skeletal muscle fiber that communicates with the somatic nervous system. So that alpha motor neuron also releases acetylcholine, which is going to bind to cholinergic nicotinic receptors. All right. So our next question. Cholinergic muscarinic receptors can be found on the effectors or organs innervated by the sympathetic fibers. That one's going to be false, okay? So a couple of different ways you could restate that to make it true. We could say that cholinergic muscarinic receptors can be found on the effectors or organs innervated by parasympathetic fibers. That's correct. Or I could say that adrenergic receptors can be found on the effectors innervated by the sympathetic fibers. Either way. Okay? Next question. The adrenal medulla is a modified parasympathetic nervous system gland. That's false. Okay, it's false because once that acetylcholine binds to those nicotinic receptors, it causes epinephrine and norepinephrine to be released. Primarily epinephrine, but still we see that is going to be exhibiting that sympathetic response, where once that epinephrine binds to, let's say, a beta-1 receptor, we're going to see an increase in heart rate. So it's going to be excitatory to that sense. So we say it's a modified sympathetic branch. Why is it modified? Well, as we said in the last video, it's a one neuron chain, so there's no post-ganglionic fiber, so to speak. All right, next question. Okay, so actually this is more of an overview, not so much a question, but that leads right into our next kind of set of questions. So this is a concept that neurotransmitters binds to the appropriate receptors to elicit a response. So one given neurotransmitter corresponds with a given receptor, and it's kind of like that lock and key method. Okay, so the neurotransmitters that are involved in the autonomic nervous system and the somatic nervous system, part of that efferent pathway, are acetylcholine and norepinephrine. And again, to recap, the receptors that bind with acetylcholine we call cholinergic, and those that bind with norepinephrine or epinephrine we call adrenergic. So there's two different types of cholinergic receptors, like we said. Those nicotinic, they bind with acetylcholine on all postganglionic cell bodies once it has been released from the preganglionic fiber, and it's excitatory, meaning once it binds to those nicotinic receptors right here, it's always going to excite this postganglionic nerve to fire and to release more neurotransmitter to bind to these tissues. So nicotinic receptors, whether it's in the autonomic nervous system or the somatic nervous system, it's always going to be an excitatory response. So if it's released, it's always going to make muscles contract, or it's always going to make these adrenal medulla pump epinephrine. Okay, and the muscarinic receptors bind with acetylcholine on effector organs once it's been released from the postganglionic fiber of the parasympathetic nerves. And we say that it can be excitatory or inhibitory. And as I said in the last video, this excitatory or inhibitory classification is really organ specific. So I thought I had a little table to illustrate that. So what I mean by it's organ specific, well, it'll cause an excitatory or inhibitory response depending on the tissue that it binds with. So an inhibitory example, as I said previously, would be acetylcholine binds to muscarinic receptors on the heart, slowing or inhibiting that heart. Okay, so it slows down the heart rate. An excitatory response would be it binds to our pupils, causing those pupils to constrict and so forth. So just kind of terminology you're going to see. Oh, and this was a table I was looking for right here. So feel free to pause it and just kind of look through these responses, and what you'll see is that the sympathetic stimulation, all of the responses are going to be things that will be beneficial in an emergency situation, and the parasympathetic would be more for everyday situations. All right, next question, or next set of information I should say, going into the adrenergic receptors. So these are what are binding with norepinephrine or epinephrine, and they're found on the effector organs innervated by the sympathetic nervous system. Okay, so we have our alphas and our betas, and good rule of thumb and a good way to work through it is that the ones are always excitatory, and the twos are always inhibitory. So our alpha receptors are found more, I guess you could say, the peripheral aspect of our body, so to speak, whereas our beta receptors are more going to be in that cardiac, pulmonary portion of our body. So, for instance, our alpha-1 receptors are going to cause an excitatory response on our blood vessels. So it's going to cause vasoconstriction on our blood vessels. And the reason this is important, this is what's happening in an emergency situation, is that we're going to have vasoconstriction in areas like our digestive tract so that we can shunt that blood off to our skeletal muscles, or areas that are going to be really active in an emergency situation. So we have basically a local movement of blood to that most active tissue. Alpha-2s are inhibitory, and what they're inhibiting is our digestive organs. Okay, so it's going to slow down peristalsis, or that circular, that movement of the digestive system, the stomach, intestines, and so forth. So it's going to slow down our digestion. So you've probably seen this come into play, or if you've ever tried to go for a run like right after eating, it usually doesn't go over so well. Why? Well, because that blood is going to be moving off to our skeletal muscles and out of our digestive system. So once that adrenaline, that norepinephrine is released, it's basically that blood is going to go to the areas where it's most active. All right, our beta receptors, as I said, they're more located within the heart and the lungs. Our beta 1s, we're going to say, are cardiac specific, meaning they're located right in the heart, and they're excitatory, meaning they make that heart pump faster, so increasing our heart rate, and stronger, so more blood per ejection. Our beta 2s are going to be found on arterioles and bronchial smooth muscle, and it's going to inhibit them. It's going to inhibit them from contracting, so that vessel radius is actually going to get bigger. So as you make that radius bigger, that opening bigger, more air is going to be able to get through. And that makes sense. If you're in a fight or flight situation, you're going to want to be able to take as deep as breath as possible, to be able to respond to that, stimulus. So kind of just a recap of those. So definitely know what each of these receptors will do when we have norepinephrine bound to them. Okay, last concept that I want to introduce, or really review, because we spoke about it in lecture, are agonists and antagonists. And these are chemical agents that either block or mimic a neurotransmitter or receptor's response in the body, which bring about a certain response. So an agonist, they mimic a neurotransmitter. You can think about they have the same response of a given neurotransmitter. Whereas an antagonist blocks a neurotransmitter. So think about that lock and key. It blocks that, lock, so to speak, so that the key can't bring about its response. So kind of a concept check going off of that. A beta 2 agonist would cause bronchodilation, increasing airflow in the lungs. That is true. Okay, it's going to cause bronchodilation. So, if it bronchodilate, we're going to have an increase in airflow. Next, a beta 1 antagonist would increase heart rate and strength of contraction. That would be false. It would be the opposite response of that beta 1 response. So we would see that it would actually decrease our heart rate and strength of contraction if it was an antagonist. Next one, when norepinephrine binds with with alpha-2 receptors, there is an increase in stomach motility and digestion. Well, that's false. Remember, if it's 2, it's inhibitory, and it's going to be inhibiting that stomach from motility and digestion. Next, the binding of norepinephrine to alpha-1 receptors causes vasodilation in peripheral vessels. That is false. It causes vasoconstriction. The binding of ACH to nicotinic receptors always elicits an excitatory response. That is true. It will. The binding of ACH to muscarinic receptors on effectors innervated by parasympathetic fibers always elicits an excitatory response. That is false. So take a look at the last video I posted to get a little more of an insight into that. The last question, the skeletal muscle contraction can be inhibited by, the answer would be C. So go ahead and take a look at the last video to get a little more insight into that. So that'll be the end of my video for today. Feel free to leave any comments if you have any questions, and I hope to see you at SI. Good luck studying.